Hey guys, it's Mary and welcome back to Study Journey. I'm back with another AMC 12 problem of the week video, and this is also a really hard problem using Vandermonde's identity and combinatorial identities to solve the problem. So without further ado, let's get on with the video. This is AMC 12A problem 15 from the year 2021. A choir director must select a group of singers among 6 tenors and 8 basses. The only requirements are that the difference between the numbers of tenors and basses must be a multiple of 4, and the group must have at least one singer. Let n be the number of different groups that could be selected. What is the remainder when n is divided by 100? And here are your answer choices. So the keywords here are that they must select a group of singers from 6 tenors and 8 basses. And the requirements are that the difference between the tenors and basses selected has to be a multiple of 4. And there has to be at least one singer. So it can't be no singers as a group. And it is asking you for the number of different groups that could be selected. And the ultimate question is to find the remainder when n is divided by 100. So the first step that you need to do is find the number of different groups, or n. So first, let's let there be T tenors selected and then E basses selected. So basically what this means is in a group of 6, you're choosing T, and then in the 8 basses, you're choosing B. The things that it must fulfill is that it has to fulfill the 2 requirements. One is that T minus B, or the difference between the 2 selected, has to be a multiple of 4. So I'll say for K. It has to be at least one singer, so T plus B cannot equal 0. So these are the things that it must fulfill. Now the first thing we have to look at is that T minus B has to be a multiple of 4. So the multiples of 4 can be 0, 4, -4, and -8. Why is this? Because we can have 0 tenors and then 8 basses, and then the difference would be -8. And then if we had 0 tenors and 4 basses, we would have -4. And then if it was they both have 4, then it would be 0. And then if we had 6, which is the most tenors you can have, and then 2 basses, you would have 4. Now, basically, this is the things you're looking at when it is T minus B equals 4 case, because these are all multiples of 4, and this is the only ones that are possible for this scenario. So now we're going to have casework. So basically, it can either be -8, -4, 0, or 4. So if the difference between both of them is -8, so if T minus B is equal to -8, then that is saying 6 tenors, you're choosing none of the tenors. And then from the group of 8 basses, you're choosing all 8 of them, hence the 0 and 8. And then for the second one, when T minus B is equal to -4, there's multiple possibilities. So since the difference is -4, the first number it can be, the lowest number is 0. You can't have a negative number of people. And then the highest number is going to have to be 4, because let's say K from 6. And then from the 8, we're choosing K plus 4, because we're trying to have a thing where it states B is equal to T plus 4. And this is from right here. We can plug that in right there. And then for this third scenario where T minus B is equal to 0, we know that T has to equal B. So in this case, the most it can be is 6, because the number of tenors is at most 6. And then the lowest it can be is none of them, so it has to be starting from 0. So you're choosing K from 6, and then you're choosing K from 8. But remember, we have to exclude 0, 0, because even though they are the same number, we cannot have 0, 0, because it says that T plus B cannot equal 0. So this whole thing, you have to subtract 1. And then for this fourth scenario, it is where T minus B is equal to 4. And then so B would equal T minus 4. The smallest it can be is 4, and then the highest is 6. So you're choosing K from 6, and then for 8, from 8, you're choosing T minus 4. And when we are simplifying, there are 2 identities that we're going to use. The first one is the combinatorial identity, which states that if you're choosing K from N, this is equal to choosing N minus K from N. So basically what this is saying is if you're going to choose K from the total number N, it is the same as choosing the leftovers after choosing k from the number n, because that is going to be the same. For example, if you had a group of numbers and you're choosing 3 of the numbers from this group of 7 numbers, it is the same as choosing 4 of the numbers from the 3 numbers, because you're still separating it 3 by 4. And then the second identity, which is probably the most important and the hardest one in today's problem, is Vandermonde's identity, which states that in the summation formula where the lowest number is 0 and the highest number is r, there's this thing where if you choose k from m times r minus k from m, this is equal to m plus n, and you're choosing r from that. So basically what this means is if you're trying to choose r numbers from a total amount of numbers, choosing a specific number from one group and then choosing the remainder of the numbers that you need to choose to get r from another group. Now we can simplify. So the first part right here, where it is 6 choose 0 and then 8 choose 8, if you're choosing 8 numbers from 8 numbers, that is the same as choosing none of the numbers from 8, because there's only one possibility for each of these. So if you're not choosing any numbers from a group of 8, and if you're choosing all the numbers, there's only one possibility. So this is going to just be 6 choose 0 and then 8 choose 0. And this simplifies down to 14 choose 0. And then the second part, we're going to use the combinatorial identity in this case. So right here, and this is also another n choose k. So in this second part right here, we had to rewrite it until it's something like r minus k, so we can use the Vandermonde identity. So how would we simplify k plus 4, choosing k plus 4 from 8? Well, this is equal to n minus k from n. So since n right now is 8, then we can rewrite this as 8 minus k plus 4. And this will simplify down to 8, and then it's 8 minus 4 minus k, so that is 4 minus k. Because this is equal to this, then basically we're choosing k from 6 and then multiply it by the 4 minus k from 8. Since we know that the r right here is 4, looking at this identity right here, and r also right here is 4, these two match up, and so we can use Vandermonde's identity. So we can simplify this to m plus n, which is equal to 6 plus 8, which is 14. And the bottom number is r, which is 4. So this is 14, choose 4. Now the next step is the exact same, and so when we are doing this, we're going to use these two identities, and then it is going to simplify to 14 choose 6 minus 1 plus 14 choose 2. And choose k is equal to n factorial over n minus k factorial over or times k factorial. So basically, if you're trying to choose 0 from 14, this is going to be 1. And then 14 choose 4 is going to be equal to 14 factorial over 14 minus 4 factorial times 4 factorial. So factorial is from this number, you multiply it by 1 less than this number and all the way down to 1. So this will be equal to 14 times 13 times 12 times 11 times 10, etc. And since 14 minus 4 is 10, so this would basically equal 14 factorial over 10 factorial times 4 factorial. Well, we know that 14 factorial is 14 times 13 times 12 times 11 all the way down to 1. And we can see that 10 factorial is from 10, so it's 10 to 1. So basically this would cancel out with the rest of this, and then it would just leave us with this over 4 factorial. And then so we would simplify, and then it would get us 1001. And then we do the same with the rest. And then we add them all together for 4095. So the question is, this is a number for n, right? But what we're looking for is what is the remainder when n is divided by 100. So 4095 divided by 100, it is going to be a remainder of 95. So looking at our answer choices, we can see that the answer is going to be D, 95.